Okay, this recording is for Le Chatelier's principle, experiment number 10, chemical equilibrium in Le Chatelier's principle. So this is showing you on the first page a generic equation where you have A and B reactants, C and D products, and then the lower script A, B, C, D is balancing the equation. So an equilibrium is an arrow that goes both forward and backwards. And the whole concept or idea of this lab is we can push the reaction towards product or pull it towards product or even back to reactant by changing the amount of A, B, C, and D. So for example, if I add more A, so if it's in equilibrium, which means there's some product and some reactant, and I add more A, then maybe spider. Got it. No, I didn't. See it? Where'd it go? I think it's gone. Goo in between my books. If I add more A, then it's going to push the reaction towards C. If I add more B, it pushes the reaction towards C. If I add C or D, it pushes it back the other way. So we can shift the equilibrium to the right by adding more A and B. We can shift the equilibrium to the left by adding more C and D. So that's pushing the reaction. If you add more to one side, it pushes it to the other side. We can also pull the reaction. If I want more product, I can remove D, and now there's not enough D, so it pulls the reaction forward, trying to replace what I removed. So removing C or D pulls the reaction forward. Removing A or B pulls the reaction backwards. Right? They even give you a specific example. Nitrogen plus hydrogen in equilibrium with ammonia and heat. So heat can be part of the equation as well. If I add heat, there'll be too much heat on the product side. I can shift the equilibrium to the left. I'm adding product, so heat behaves like a product. It pushes the reaction to the left. If I cool this reaction down, I'm removing heat, so it pulls the reaction to the right. Right? Any reaction equation that has heat on the product side, the right side, is an exothermic reaction. If it's an endothermic, right, if I feel this, like put this in a test tube and feel it, it'll get hot because heat's being given off. If it gets cold, if I feel it getting cold, then that means heat is on this side, and as it reacts, I'm removing heat. Right, so they walk you through several scenarios. What happens if you change the temperature? If you add nitrogen, it shifts it to the right. If you add more hydrogen, it's going to shift it to the right. Right, so we can add to one side and push it the other way, right? Or we can remove from one side and pull it towards that side. Okay, so that's the basic concept of Le Chatelier's principle. In this lab, in the very first part, you're looking at this equation, iron 3 plus thiocyanate becomes iron thiocyanate. So the first thing they have you do is put a couple drops of iron nitrate in with potassium cyanide, and that looks like this. So your job is to write down what it looks like. What color is that? Right, so originally, iron nitrate, FeNO33, iron nitrate is this yellowish orange. But then when I add the potassium cyanide, thiocyanate, KSCN, it's colorless. It looks like water. When I mix them together, when I mix these two together, it looks like this. So write that down as your result on your data page. That color gets written down right here. What does it look like? Then it tells you to add more of the iron nitrate. So if I add more of this, more iron nitrate, I'm shifting this chemical reaction. Dang it, where's it at? Flip the page, that's not it. I'm shifting this equation. So this one is the yellow, the kind of orange yellow, and then the product that we produced is FeSCN, which is kind of this blood red. Well, what happens if I add more of this yellow? If I add more to this side, I should shift the equilibrium to the right. So let's see what happened. If I added more of this, it turned even darker blood red. Right? So the next step is adding NaOH. So what NaOH does is NaOH binds to the iron and forms iron hydroxide, so it's removing iron, right? Remember, this is yellow, orange, and this is blood red. So which way does it go? If I remove this yellow, orange, what happens? It should pull the reaction to the left. Remember, this is the color of the iron, Fe+3, yellow, orange, yellowish, I guess. FeSCN is blood red. What happens when I add NaOH? Well, NaOH binds to the iron. NaOH has no color. It looks like water. But what happens is it shifts it to this color. So the one on the far left here is after adding the NaOH. So this is adding more, this is the original. This is adding more iron nitrate, and this is adding NaOH. So you're supposed to write down your observations on the data page, which is here, what happened in each one of those cases. And then in the next part of this lab, we took ammonium nitrate and added water. And for this particular part of the lab, you cannot, I can't put this on video, but that's ammonium nitrate. All right, ammonium nitrate. I put some in a test tube, that white solid. I put water in it, and then you're supposed to feel it. And what you feel happening, you're not here to feel it, it feels cold. So it gets cold. So we're looking at this equilibrium, iron nitrate solid, adding water and turning it aqueous. Aqueous means dissolved in water. It gets cold, so your job is to decide, is it exothermic or endothermic? Is heat produced as a product, or is heat absorbed as a reactant? So your job is to write down added water, it got cold. So then you write the equation adding heat either on the product or reactant side. You're rewriting this equation, adding heat to one side or the other, and then deciding, is it exothermic or endothermic? Okay, so we're done with this part. We're almost there. So now, concentration effects. We're taking cobalt nitrate and adding HCl. So cobalt nitrate looks like this. All right. Yep, that's cobalt nitrate. It has kind of this, I don't know, brownish red color, rusty red maybe. So I'm going to put some in a well just so you can see it. All right. So on the left here, it's kind of that color. And then the procedure tells me to add HCl. Well, in a separate well, it tells you to put HCl. HCl has no color. And then you add them, mix them together, and it turns this color. Without that, well, here, I'll mix them together. So I pick up the HCl, I add it into here, and you can see what happens. Right, it kind of turned blue. So it went from this reddish color to this blue color, just by adding HCl. So what equation are we looking at now? If I can find it. So here it is. It's on the bottom of the second page. Cobalt hydrate. It says in this paragraph up here, cobalt hydrate, octahexahydrate is pink. And then it tells you cobalt chloride is blue. So what I did, I said, I took this pink. I guess that's pink. Maybe this bottle looks a bit more pink. I don't know. More of a red than a pink. And I added hydrochloric acid. It's a source of chloride, which was colorless, and it turned blue. So what I did is I added Cl and I shifted the equilibrium towards blue. So now it says to add water, and when you add water, water is a product. Water is going to shift it back to the left, shifting it back to the left. So let me get some water. Here I have a bottle of, sorry, got to use both hands. This is a bottle of deionized water. Of course, water is colorless. And I'm going to add water in here, and you'll see what happens. And it went back to pink. So then it says to add calcium chloride. It's a solid. So I will do that. Take some calcium chloride here, which is this solid. I just need one little piece. So this one little piece is enough. And I'm going to drop that into this well. And what will happen over time, that piece may not have been big enough. What will happen over time, okay, you can start to see it changing. Over time, as it kind of mixes a bit, do you see what's happening on the surface? See, it's kind of turning blue around it. Over time, it'll look like this. Yeah. So what is happening is calcium chloride, this white solid that I put in there here, is hygroscopic. It absorbs water. Right? So I added some calcium chloride, and it absorbed water. And around the calcium chloride, there's the absence of water. So what does that do to the equilibrium? Right? It's kind of turning blue. Right, where the calcium chloride is. What does that do to this equilibrium down here? Well, if I'm absorbing water, I'm removing water. I'm using calcium chloride to absorb it, so I'm shifting this equilibrium to the right, but it mainly only happens right near the surface of the calcium chloride. Right, there's so much water in here that only right around the solid calcium chloride does it turn blue, which is kind of neat. And then the last part of this lab, dang, I don't have this set up and ready to go. So I may have to set this down for a second. I'm gonna set this down, and I gotta grab a test tube, which I do not have. And the procedure says to take some cobalt chloride and then add some HCl. It says 5 milliliters and 2.5. I'm not being real careful about it. That looks about right. Okay. Good. I have to divide it up between test tubes. Okay, so now what I did is I took this cobalt chloride, kind of a, I don't know, reddish rust color, and this concentrated hydrochloric acid, and I mixed it together, and it gives me this, I don't know, pinkish blue. What would you call that? Whatever you want to call that, write it down. So this goes in one of these, write down this color, I'll show you here in a second. One of these is going in hot water, and the other one is going in ice. And in your data table, if I can find the right page, it's on the back. So this is the adding HCl, water, and then calcium chloride. That was this result. Now we're doing the very last part of the lab, which is temperature effects. So I mixed the cobalt chloride and the HCl. I divided it between tubes. And I don't know, they look like, I don't know, kind of an off red color, I guess, initial color, whatever you think that initial color was. And then what does the color change in the hot water? What does the color change in the cold water? Is it reversible? So let's go and look. What does it look like in the hot water? It turned almost purplish blue, like a purple blue color. And what does it look like in the ice? Yeah, it's kind of that, I don't know, peachy pink and ice. So is it reversible? Well, I'm going to take the one from the ice and put it in the hot water, and one from the hot water and put it in the ice, and we'll see if it changes colors. So what I'm doing is I'm looking at whether this reaction is exothermic or endothermic, and hopefully you can see that is changing. It was kind of a light pinkish color and is turning darker and darker. It's getting more and more blue in it as it's in this hot water. All right, so now where it was pink, it's now blue in the hot water. And the one that's on ice was this dark blue. Here, I'll compare it. The one on the left was in hot water. The one on the right was in the ice water. You can see if I put it in ice, it kind of turns a peachy pink. And if I put it in heat, it turns a purpley blue, and it is reversible, right? I could reverse it again. Put the pink one in the hot water and the blue one in the ice water, right? I can keep going back and forth between these. So they change colors with temperature. So your job is to use that information, right? The one in the heat is turning purple blue. You can see the purple forming in it. And the one in the ice is turning peachy pink. Right? So your job is to write down, decide is it reversible? And then answer these post-lab questions. So all you have to do is turn in these two tables filled out here with just what you observed, what colors you saw, along with these, what colors did you see, right? The only one that you didn't see was this one. When I added water, you're supposed to feel it, and it gets cold. So that's all you have to write here. It got cold. Then you have to answer these questions. Okay, so post-lab questions down here, you're turning in these tables, just this one page. One side is your observations here for the first two parts, your observations here for the second two parts, and then answer these post-lab questions. There's not a whole lot of room here, so I would write this on separate paper and turn it in. I mean, you could use the space up here and the space down here to answer these questions, but spread them out. Don't try to squeeze everything in here. It'll be hard for your professor to grade. Okay, so that's it. We are done with this particular lab. Just showing you one last time the results. Part 1. This is part 3. And then the last part. Wow, this is definitely a bluish color now. And that's definitely a pinkish color. So in heat, it's bluish purple. And ice, it's kind of a pink color. Peachy pink. Okay, stopping this video now.